Good morning, Baya students, grade 11. Today we are going to solve a problem about moving different objects using a pulley by applying Newton's law and the energy formulas. Please read carefully the text. Calculate at t equals to 0 the mechanical energy of the system M1, M2, and M. As we all know that mechanical energy equals to kinetic plus potential energy equals. Kinetic is zero since the system starts from rest. It's mentioned in the given. So the potential energy gravitational for each particle M1 GH1, M2 GH2 plus MGH. M1 was at O, which means at the reference, no height, so the potential energy is 0, plus M2 is 4 times 10 times M2 was 25 meters above the reference, so it will be times 25, plus potential energy for the pulley, mass of the pulley 1, gravity 10, distance, height M1 was, or M was at a distance AB from the reference, so it's 50 meters. So the answer will be 1500 joules. Now in part 2, M2 follows a distance x, so M1 will move a distance x along OA. Back to the figure, as we can see, if M2 moves downward by 25 by x, so the height will be 25 minus x here. M1 will move a distance x because the massless string, inextensible string. So the string is inextensible. This means that x equals x1 equals to x2. And the height of the pulley doesn't change. It's still 50 meters. So 5 times 10 times x sine alpha plus 4 times 10 times 25 minus x plus 1 times 10 times 50, and the whole answer will be 1500 minus 20x. Deduce the expression of the kinetic energy in terms of x. As we all know that kinetic energy equals to mechanical energy minus potential energy. Mechanical energy is conserved since no friction, 1500 joules, minus 1500 minus 20x, minus times minus, it will be plus. Show that the kinetic energy of the system in terms of V is given by 5v squared. Kinetic energy equals half m1v squared plus half m2v squared plus half I theta prime squared. As you can see here that all speeds are the same. V for 1, V for 2, which means that M1 and M2, because the string again is inextensible, plus half I theta prime squared. I equals to mr squared, considered as a hoop. Theta prime is V over R. Substitute I and theta prime to the power 2, it will be mv squared. Add them, 2.5 plus 2 plus 0.5, the answer will be 5v squared. Use the results of part 3 and 4 to show that the acceleration is 2 meters per second squared. In part 3 we proved that the expression of the kinetic energy is 20x. In this part we proved that it's 5v squared. We have to derive by the convenient derivation. V squared is 2v v prime, and the answer you will get will be 5 times 2, 10, v times v prime a equals 20 times derivative of x is x prime, which is v. In part 6, apply Newton's law in translation and rotation to find again the acceleration. You have to do the whole as we used to do at classroom, the whole derivation, but previously system for M2, sigma F external equals to MA. The result will be M2G minus T2 equals M2A. System is M1, sigma F equals MA minus M1G sine alpha plus T1 equals M2A. System for the pulley, T1 minus T2 minus T1 equals to MA. Solving the three equations by substituting T1 or T2 from 1 and 2 in equation 3, you will get the same answer, which is 2 meters per second squared. Hope to see you as soon as possible. Stay safe and study well.